removing from a hash table is a little more complicated than insertion, and I can show in this short example why. So let's say for removing, for this example, we're going to do linear probing. So linear probing is our method for handling collisions. So given our hash function and our compression function, we're going to say 3, pass in 3, and get back 3. So 3 is going to be our hash code, and we're going to compress 3. So 3 mod 6 is going to be 3. So our value is 3, 5. All right, so done. Now we want to insert or put 2714. So pass in 27, get back 27. 27 mod 6. So 6 is a multiple of 24, and that's the difference of 3. So we want to put it in this spot. So we have a collision. So we're going to handle it with linear probing. So take one step and see if it's open. So put 2714. Okay. So this is done. Now we want to remove 3. Okay. So find the key 3 and remove it. So pass in key 3, get back 3. Path 3 mod 6 length of the table. We expect to find this key at index 3. Okay. So we look at index 3. Cool, we found it. So we want to remove it from the table. So let's go ahead and remove it from the table. So now our value is no longer there. Okay? All right, so now we want to get 27. So find 27 inside the table. So key 27. Pass in 27, get back 27. Pass in 27. 27 mod 6 is going to be 24 with a difference of 3. So we expect to find it in index 3. Right? So we look in index 3 and it's empty. And we say it's not in the table. We can't find it. It's not there. So removing, you have to be careful. Removing, you don't actually ever remove from a hash table. You mark it as invalid. Okay? So when we removed 3, this was 3, 5. What we're going to do is, instead of removing it from the hash table, we're going to mark this as invalid. So if I try to look for data 3, then it's going to return null, nope, can't find it. Even though it did find 3, even though it did find this key, it's going to return null because that's an invalid object inside that spot. So if I mark this invalid, now when I call get 27, this looks to this index 3 where it expects it, and it says this is invalid. So there could be data after it that got pushed down by linear probing or whatever collision technique we use. So what happens is I look in index 3, it's not there, but this is an invalid, there's actually data there, so it could be later on. So linear probing says take one step and see if it's there. So now I look here, and I find key 27. Good. So make sure that when you're removing in actual code implementations, don't actually make this entry null. You want to mark it invalid, and that's true for probing techniques. For external chaining, for external chaining, instead of pushing it down, we'd make it in a linked list. So when I say get, actually, let me just do that real quick. So when I say get 27, so on this collision here, when I put it in, 27, let's write 27. 27 and 14. So now when I say remove, then I can actually take this out of the linked list and I don't have to worry about it. If we don't remove it, then when I go to find it, I have to iterate through the entire linked list until I find it or until I realize it's not there.